Hello friends, in this video I am going to solve exercise question from book Topics in Algebra. So question is, if H is a subgroup of G, let N is equal to intersection of all H inverse for all elements X in G, then prove that N is a subgroup of G such that A inverse is equal to N for all elements A in group G. So firstly we will prove that N is a subgroup of G. For this we will use the lemma, a non-empty subset H of a group G is a subgroup of G if and only if for all elements AB in H, A star B inverse is again an element in H. So proof is, here G is a group and H is any subgroup of G, and N is intersection of all H inverse for all elements X in G. Now observe that as H is a subgroup of G, so identity element E will be a member of H, and for all elements X in G we can write E as X inverse. So from this we can conclude that E will be an element of N. Thus N is a non-empty subset of G. Now consider any two elements, say N1 and N2 in N. Then N1 and N2 will belong to this intersection, and as N1 and N2 are in this intersection, we have N1 and N2 will be elements of X1 H X1 inverse for some X1 in G. Thus we can write N1 as X1 H1 X1 inverse and N2 as X1 H2 X1 inverse for some H1 and H2 in H. Now consider N1 N2 inverse. So that will be X1 H1 X1 inverse, X1 H2 X2 inverse, its inverse. In the next step this will remain as it is, and this can be written as X1 H2 inverse X1 inverse. This thing follows from Sokshue property. Now X1 inverse X1 will be identity element and remaining elements will remain as it is. Now H1 H2 inverse can be written as H3, since H1 and H2 are elements of H and H is a subgroup of G. So we get N1 N2 inverse is equal to X1 H3 X1 inverse for some H3 in H, and thus N1 N2 inverse will be an element of set X1 H X1 inverse. Now observe that since X1 is any arbitrary element of G, and if N1 and N2 are in X1 H X1 inverse, we get N1 N2 inverse is an element of X1 H X1 inverse. Thus for all X in G and N1 N2 in H X inverse, we have N1 N2 inverse is an element of X H X inverse, and as this thing holds for all elements X in G, we get N1 N2 inverse will be an element of intersection of all X H X inverse for all elements X in G, and this implies N1 N2 inverse will be an element of N, and this implies N is a subgroup of G. Now next we need to show that A and A inverse is equal to N for all elements A in group G. For this consider an element, say G in A and A inverse. If this thing is true, then we have G is equal to A and A inverse for some element N in subgroup N. If this is true, then we get G is equal to Ax H x inverse A inverse, since n is an element in n, so n will be of this form for some H in subgroup H, and if this thing is true, then we have G is equal to Ax H Ax its inverse, since this can be written as Ax its inverse. So finally we get, if this is true, then G can be written as A1 H A1 inverse for some A1 in G, and thus we get G is an element in N. Therefore, as all these arguments are if and only if arguments, so we have An A inverse is equal to n for all elements A in G, and therefore n is a subgroup of G, such that An A inverse is equal to n for all A in G, and this proves our result.